see how we go. Okay, so today we're talking about further graphs. So the first one we're going to talk about sector graphs. And so as the name suggests, the sector is this section. This is a sector. This is a sector, a circle. And so it's basically just a piece of the pie. Can't think of a cake, you're slicing it up. That's what a sector means, in case you're in any doubt. And so it's also called pie chart. And so it's called a pie chart as well. So obviously you've got something like this. Hands up if you've never seen a pie chart before. Okay, so you don't have to draw it. Just make sure you're familiar with what a sector is, a sector graph, pie chart, all that sort of things. Right, so now if we have a look at this example here, it's just got, if you can't see, it says student grades. Can you see those percentages?
Let me just close it and open it so the pen will work.
So it's not the clearest. So you've got the 4 different colors. That's C. This is a student grades from a particular school. That's 7.1%. That's 14.3. That's 42.9. And this one is 35.7. Alright, so that's A, B, C, and D. So what percentage of students got a grade higher than C? What percentage of students? So, Franco, what's a grade that's higher than C? And? B and both A and B are higher. Alright? So B is this one, which is 42.9. A is 14.3. What is that, Alex, if you add them together? What percentage? What is it? 57.2. Good. So it's 14.3 plus 42.9, which equals 57.2%. Okay, so I'm just reading off what it tells me. So often, if you do one in Excel, for instance, it will tell you, or you can set it so it tells you the percentage, or it tells you the score, which means you can find the percentage. Now, the other thing here is, if the U group has 70 students, how many students got an A? Right. How are we going to work this one? There's 70 students. How do we work out how many got an A? Well, 14.3 is a percentage. So it's the other way around. So we're finding a percentage of a quantity. So it's 14.3 over 14.3% is 14.3 out of how much? 100. So it's 14.3 out of 100 times 70. And Ellie, could you find this out, please? .3 over 100 times 70 is basically very close to 10.01, so we'll just say it's 10. Okay? 10 students. Okay, nearest whole number. Any questions about it? Reading off the sector, working out a percentage on the quantity. The way I remember these sort of percentages, you keep percentage together. If you're finding a percentage of a quantity, it's the given percentage over 100 times the quantity. If you're finding a quantity of another quantity as a percentage, you put that over the total and multiply by 100. Okay? So that's the way we need to think about it. We'll just move it up a little bit. And so in some cases, the percentage of the sectors are given to you. So in these cases, the percentages are given to us. But there's also cases when it may not. And these sort of cases can happen in exams and assessments, or it may just be given to you in whatever context. And so you may need to use a protractor to work out the percentage. Okay, which means you have to work out what the angle of the sector is inside the circle, and then you find that angle as a percentage of 360. And I have something here, which if you just care to look, let's see if we can figure this out. So, how do I make it? How do I make it big? No. Was that? This one? Oh, here we go, thank you. So it's been a while. Anyway, so here we have a protractor. So this little survey is, do you believe that video games can be an effective learning tool? Let's make a little survey. Who thinks video games can be an effective learning tool? Yeah. I saw a news report actually that games are considered now to be better than TV. So for kids to play an educational game on the iPad, apparently it has more value than watching other topics. Anyway, anyway, the point is, here we have this graph, this pie chart saying, do you believe that video games can be effective learning tools? So the blue section is elderly people saying yes, and then adults. So this is the percentage of people that said yes to the question. So this many, the purple is the percentage of adults, and the teenagers is out of all the people that said yes, this many teenagers said yes. So if I go back to the question, we need to answer these two questions. What percentage of people who answered the question were teenagers? Let's just write that question now, we're going to have a look at it again. And then the second one, if there were 300 people surveyed altogether, how many were elderly? Alright, so we want to find the percentage of teenagers. This is the way we have to do it. So we get our protractor, and the teenagers is the green. Now we just know that a semicircle, the angle here is 180. Alright, we all know that. That's 180 degrees. And so we just need to find what this angle is in here. So if you have your protractor, has anyone got a protractor with them today, by the way? Okay, and then we switch it around. No. Do it. Anyway, let's estimate. So we've got technology is wonderful. So you've got, you start here, I would say about 35 degrees. Agree or disagree? This is 35 degrees. Okay, so the total for teenagers equals 180 plus 35, which equals 215 degrees. Alright, so we know that it's 215 degrees out of 360, so we now need to find 215 as a percentage of 360. Here, what percentage of people? So it's 215 degrees. Alright, so I do 215 over 360, multiplied by 100. Caitlin, could you find this for me, please? Let's see how it goes. $59.7. 59.7%. Okay? 59.7% of the people who said yes were teenagers. Okay? So that's how we answered the question. Teenagers said 59.7, you can round it up to 60%. And that'll be fine. Okay, so it's always important, remember in this course it's very wordy. There's always lots of wordy sort of questions, and it's always asking, basically you need to answer the question. Often you see working out where people do all the correct working, and there's a number on the page, but that's not actually the final answer. It's just sort of the thing that you have to then use to write out a nice clear answer to the question. So make sure you're always thinking about and answering the question. Okay, and if there were 300 people surveyed altogether, how many were elderly? Right, so if there's 300 people, how many are elderly? So we have to go back to our little protractor here. Elderly is the blue, so we need to measure this and see how many. So we can do this. And so it's about, let's say, 47 degrees. 47 degrees is elderly. southerly sector makes up 47 degrees. And so we find that percentage. We have to find that as a percentage and then find that percentage of 300. So this is the way that we're going to work it out. 47 over 360 multiplied by 100 is equal to what? Bella, could you do this one? 47 over 360 times 100. .05%. Okay? And then what we need to do is find 13.05% of 300. So it continues on here, and we say 13.05% over 100 multiplied by 300, and that's going to equal, this 100 cancels out, so 3, so it's, let's say 39 people. The nearest whole number. Okay, so 39 people out of the 300 survey were elderly. Okay, so you understand the steps that I've taken. You find the angle inside that sector. You then find that as a percentage of the total, and then you have to use that percentage to find if you're given a certain number of people. Okay? So making sure that we're clear on the steps, make sure you know how to use a protractor, and use it. Any questions? Okay. So if we move up, so that's sector graphs. The next one's radar graphs that we have. Has anyone ever seen a radar graph before? Typically they're used for sort of temperature, weather, comparing over a period of time. It's a good way in a circle. It looks like this. Okay? Measures from the middle of the graph. So the middle is 0. And each line going out is a certain number of units, and it's often used with temperatures. Like I said, you can have it by temperatures over a day or over a year. This one is average monthly temperatures. I realize after I put it in, the temperatures in Fahrenheit. So we'll just deal with that. That's okay. Alright, so basically what this chart is saying is the green line represents the temperatures in Memphis. You don't know what state Memphis is in? What's famous about Memphis, right? What's Memphis famous for? No. Anyone know? Yeah. Elvis. That's right. Elvis is from Memphis. Memphis, Tennessee is. Okay? Then the red line is Sydney, and the blue line is Bermuda. What's Bermuda famous for? The triangle. Yeah, the Bermuda Triangle, where ships mysteriously get lost. Alright, so basically you can follow it around and say for January, the way you read this is you say January, you can follow it up the middle. 0, 10, 20, 30, 40, 50. So 0, 10, each line is 10 units. I'm in your way now, but you saw it before. So it's 50, and then Bermuda has 65, Sydney has about 74. Okay, this is in Fahrenheit. So we can convert it, but we won't worry, that's not the point at the moment. The point is how we read it off. Okay, so we're just making sure, and each month just go around to the next line. So in March, they're very similar, and it's a great way that you can just look at it and see the shape, how it changes in and out, and how you can compare the 3 sets of data. Okay, so it's quite a handy way to just look at it, and then of course you just have to interpret the data that you're given. So what was the highest temperature in Sydney over the course of the year? So Sydney, we have to look at the red line. And we also know that Sydney has summer in December, January, February. So that's going to influence what the temperature is. So Franco, what do you think is the highest temperature for Sydney, approximately? So where are we looking at? Here, this one? Yeah, Sydney's red. Yeah, about 75, I think. So 75 degrees. It's a bit small, so but you know, the idea is you can see that the highest point is here, and obviously in winter, in July and August, June, it's going to be much lower. And the same, the circles are the same unit. So if you follow it out, it's 10, 20, 30, 40, 52 or something. 52 Fahrenheit is the winter temperature in Sydney. And then the next one is, what was the lowest temperature in any of the cities in that year? Okay, so we can look at all the three rings. What was the lowest temperature out of all the three cities? You had a green one in which month? January, yeah, I would say so too. So January, so that's Memphis, which you would expect, and so central US, and it's 50 degrees Fahrenheit, which is approximately what? Something like that, yeah. Anyway, Fahrenheit is a funny little system. Okay? So we understand. Are there any questions about the radar graph? Okay, you start from the center. So it's like a radar. You know, you're in the center in a way, and you're reading out to make sure that you're seeing and comparing the different lines that are going around. Okay? Two more things we're going to talk about, and then we're going to do some work on the exercise. A step graph. Alright, so basically the point about a step graph is that it's a line graph that has breaks. So you will go for a time, or a line will go and then there's a step up, and it goes along and then a step up. So this is a very simple example. And a solid point, so filled in circle or filled in point, means that that's included in that line. So this point is, so 7-year-olds start at 8. Whereas 9-year-olds don't start at 8 a.m. because that's an open circle. That's not part of this line. They start on the solid. The solid line is 9 a.m. So you jump up. Once there's an open circle, you go to the solid one, and that's counted in that part of the graph. Okay, so open circle means you don't include it. Closed circle means you do it. So to answer a couple of questions, at what time did the 10-year-olds begin? What time did they start their event? What time did the 10-year-olds start their event? Yeah, so 10-year-old is here. We follow it up. Hits it at 9 a.m. So we start at 9 a.m. Okay, so very straightforward. And then, Alex, what time did the 15-year-olds start their event? Yeah, so we follow up from 15. If we go up here, we don't count this one because it's open, so we go up to the closed dot, and so that's 12 p.m. Okay? So at noon they started their events. So that's the way that we read those. Okay, remember, closed dot. This is true in all sorts of graphing, it's just a convention. You also do it in high level of maths when you have certain types of graphs. It takes a jump up or it steps. So this is called not continuous, no need to worry about that. But in those cases as well, if the value jumps up, it's a closed dot when it's included, it's open dot when something's not included. Okay? So that is step. The most important point being about the open and closed circle. And then the final one we're going to look at is comparing two or more sets of data. Okay, and graphs are very good to be able to present more than one set. So, for example, you can have a column graph. I'm not going to go through every possible type of graph with two sets of data. You can have line graphs, if there's some in the exercise with line graphs or column graphs. All sorts of, you can have radar charts, obviously. You can have two pie graphs next to each other, whatever else. But this one is saying, well, how people get to school. So there's group 1 and there's group 2. So the blue is group 1, the red is group 2. And it's saying this is private car. How people get to school is by car. That's a percentage. Train, bus, taxi, bicycle, walk. Has anyone here ever gone to school in a taxi? It's interesting. I've never done it. So if we have a look at the questions, we say, well, what percentage of group 1, which is the blue, what percentage of them take a car to school? Private car. Come. Yeah, that's a good estimate. So we're looking at private car, we're looking at this one, and so it's going to be about 39%. Okay, so 39% of group 1 goes in a car. What percentage of group 2 walk? 22%. So again, we're looking at the walking, and we're looking up at this column here, so we say about 22%. And then these sort of questions, I was just looking at a past paper recently, of a general paper, and they love these sort of questions about, you have this set of data, and you say, well, make a conclusion about what this data says. Alright, so make one comment about the location of each school and the available transport. Brandon, what do you think? Looking at this graph, make a comment about the transport and the location of the school. Yeah? So more people have to drive. Yeah, good. So something like that is good. So for example, we could say group 1 school is further away from public transport, so more people need to drive. Okay, for example. There's all sorts of things you could say about it. But always remember, in these sort of topics, in data analysis, that's what it's about. It's about analyzing what you see. It's not just about using a formula or doing a graph or filling out a table. It's actually about what does this information say, because those things are tools that help us then to say something about things. Okay, so then we can make not a guess, but we can have an opinion about what this says about this particular thing. Okay, so this is a really important sort of thing to start to be thinking about, making these statements, making these observations about the information. Okay? So basically that's it. I will stop recording. Exercise 4.3 is what we're going to work on today. And so if you could start on that and make sure you